Hello and welcome to Ontology Explained. I'm Casey Hart, philosopher and ontologist, and today we're talking about stitching ontologies together. The metaphor, of course, I'm thinking quilting when I'm talking about stitching, and we've got, you can see above me, the quilt ladder. Shout out to Donna Corcoran, who made some beautiful quilts for each of my daughters when they were born. She was sort of like an adopted mom for us when we lived in Wisconsin. Amazing, her and her husband. I'm sure neither of them watch the channel, but here's a shout out on an ontology YouTube video that you'll probably never watch. Also, if you don't want quilts as your metaphor for stitching, you can think, hey, it's almost Halloween, stitching a monster together. Get a little more Frankenstein spooky vibe going on. Our plan for today, I'm going to try and be quick. Let's see if I can do it. First, what is stitching? I'll tell you what I mean by this whole thing. It's not just about quilting and Frankenstein. Implementation. When you have stitching by tying ontologies together, how does that work? And then we're going to look at the three different main cases for stitching together ontologies. Those are case 1, when you have non-overlapping ontologies, case 2, when you have overlapping but compatible ontologies, and then case 3, when you have conflicting ontologies. That's the hardest case. Let's get to it. What is stitching? Consider two ontologies, ontology A and ontology B. Then stitching A to B together consists in specifying how the various terms in A relate to the various terms in B and vice versa. So if you want just a simple example, say in ontology A, we've represented a class called person. In ontology B, we've got a class called YouTuber. A way that we could stitch those two ontologies together in that respect is to show how those two terms relate to one another. Namely that YouTuber is a subclass of person. Every instance of YouTuber is an instance of person. Sweet. We have now connected them together. And I call that a stitching triple or part of a stitching file, stuff like that. Three metaphors for ontology that will help us understand what stitching is. I did a video a while ago, and I said that ontologies are languages, graphs, and models. And I want to talk in the next couple of slides how each of those conceptions ties into thinking about stitching different ontologies together. So on the language front, when we connect two languages, right, we translate between them. So if I want to know that pancake in English is pankaka in Swedish, or I want to know that potato chip in English is shupian, I'm sure that's butchering it, but in simplified Chinese, we're going from one language to another language. And it's not always so straightforward where it's like, here's the word in one language, here's the word in another language. Often we have confusions that arise. I mean, we have a bunch of different English idiolects, right? And in British English, when they're talking about chips or crisps or fries, they're using different terms than we would over here in the United States, which are maybe different than you'd use in Australia, etc. So translating between languages isn't just among natural languages, it's among different idiolects within a given natural language. How do we connect different models together? Well, you build your little D&D miniature, and then you build a terrain, and then you put them on each other, or you set the miniatures next to each other, or you glue together different pieces of the terrain in different ways. You can use Legos, put these things together in that way. We have different models of the world, and these representations get brought together by taking the different components and then seeing where they fit. So we have three different subgraphs here, but two of them are stitched together with the H and K nodes having an edge between them. So what's going on? Why bring up those three things? Well, here's what I want you to take from what it is to stitch two ontologies together. When we stitch two ontologies, we should be able to translate from one language to another, see how the worldviews are unified in terms of a model conception, and also have a graph that results that's connected and traversable. Now, I use the term stitching, but I've considered a few other things, and there's a few other terms that you might hear in the industry. So in the common parlance, they might talk about this as ontology mapping, or alignment, or merging integration of different ontologies. Personally, I considered, and I go with stitching the vast majority of the time, but there's some other good ones. I like grafting too. Grafting sort of has more of a conception that ontologies are growing, living systems where you want to attach one part to another and they're still functioning and working. Welding is also great. It's a more structural, and another structural one is talking about bridging. Really, I'm cool with any of the above. When I create my individual files, I call them stitching files usually. So that's just the vocab term that stuck. If you use a different term or prefer one of these, drop it below in the comments. I'd like to know what folks here think. Okay, so now we know what ontology stitching is, but how does it get implemented? And it's really not that complicated. We just need to do two things. We need a set of triples that stitch our ontologies that tell us how they relate to one another. And then we need a mechanism that leverages those triples. Now, I'm not going to give you a whole bunch of real specific practical implementations here. I'm just going to talk functionally about what needs to happen if you're going to implement a stitching of two ontologies. I say two ontologies, two or more ontologies. So on the first part, how do we get the triples? Where do they live? What does that look like? Option one is you just create a new .ttl or .owl or XML file. And this file I call the stitching file. And this is where you house all of those triples, like in the initial example where I wanted to say that YouTuber is a subclass of person, right? That triple could live in this own stitching file along with all the other triples that do the stitching work. Second option is it doesn't need to be in its own file, just keep it in one of the other parent files. So if you're stitching together ontologies A and B, then maybe you could put all the stitching triples within one or the other of those files. And it might make sense if one of those ontology files is like the primary one, like the upper ontology or something like that, and something else is getting grafted in or stitched into that. Maybe the one that's being stitched in should include that stitching or bridging vocabulary within it. And then your third option here is to create an umbrella ontology that does the stitching work. So instead of having ontology A and ontology B, and those two ontologies then just have like a glue file that connects them together, a stitching file, you could also create a third ontology that's like a common vocabulary that has terms, more general terms from each of the other ontologies, as well as the stitching triples within them, and that umbrella ontology will then probably be its own file. The file structure here is pretty irrelevant. You could store all ontologies in the same file, you can put them in different files, but I think a nice standard one is you have two turtle files, ontology A and ontology B, you want to stitch them and connect them together, create a new file that we call the stitching file, and write all your connection triples in that. Okay, so once we have the triples that we want to use to stitch them together, that doesn't do anything unless we're leveraging those connections. So what is it to leverage stitching files? There are really two directions here. We can either materialize the translation or we can do a query time translation. Materializing the translation means we have some instance data or something like that, and it's expressed in terms of one of the ontology's representations. But we want to leverage the fact that that ontology is connected to our other ontology via this stitching file. How can we make use of that? Well, one way is to just like forward compute the translation. So think of this again as just like two different languages. So the Odyssey, not written in English, right? But I can buy an English copy of that because we have a materialized translation of it. Someone went and did the work and figured out how we can get from Greek to English. They write that translation and then they publish that book so that I can read it already translated. Alternatively, we can do a query time translation. So at the moment when I'm querying my data, it might be expressed in both ontology A and ontology B, but I will include the stitching file in that query context so I can look for the synonyms or translations. And this is going to be more time consuming at query time because we're asking it to do more work, but it's not very time consuming up front and we don't have to store things in as many different formats. And this really just goes back to exactly the way that we would think about setting up an inference architecture. So we know now what stitching is, and we know functionally what we have to do with stitching. Let's look at the three types of cases that you're going to run into with our two different ontologies, and these are in cases of increasing difficulty. So case one, non-overlapping ontologies. So you have ontology A and ontology B, and you want to bring them together. It's super easy if one of them is just a more general version of the other one, or they're both domain ontologies on relatively the same level, because we can just connect them in like one spot. So if you have ontology A is a domain ontology, say, and ontology B is an upper ontology. So maybe this is that YouTuber person kind of case, right? I have something like BFO or gist as my upper ontology, which would be ontology B in this picture in the green dots. And then I have a more specific domain ontology about YouTube data. Then that YouTube data is just going to sit below my upper ontology, and there'll be some connections upward with some like subclass of assertions. Alternatively, we could have two different domain ontologies, like maybe one is about biology and the other one is about chemistry, in which case maybe there's some horizontal connection between them here, right? Maybe they're related to the similar subject matter, and so we want to say that this property is the same thing as this property, and so they're linked a little bit, but mostly their concepts aren't really overlapping one way or the other. Or maybe we take something like the pink approach on the right in the graph above, where we just have two ontologies that are subsumed under some upper ontology, but really A and B are orthogonal to each other. Let's get a little more complicated. Case 2, you have overlapping ontologies, but they're compatible with one another. This is of medium difficulty, and here's the process you have to do when you have two ontologies that are about the same subject matter, but they're consistent with one another. First thing you do is you have to understand the subject matter. So here I go back to the metaphor of thinking about ontologies as languages. If you want to be a translator, you're like, man, I'd love to be a French to English translator. You first have to learn the languages. You have to be a fluent French speaker. You have to be a fluent English speaker. And once you know, then we can start going about the work. So the first thing you have to do with ontologies that you want to stitch together is you have to know both of them super well. Once you understand those ontologies, take the smaller of the two ontologies, and you could also go with the bigger. This is just, it makes an easier workflow. So if we have ontology A and B, and A is a little bit smaller in terms of like total number of named resources in it, like individuals, classes, properties, then go with that smaller ontology, A, and map it into B. And what do I mean by mapping it in? I mean go term by term, and for each of those terms, see whether it satisfies one of these. Is it the same as something else? Then say that those two things are the same. If one of the things is a subclass or subproperty of something else, then connect it with a subclass or subproperty assertion. Or maybe those two things are different things, but they would be better off if you could connect them to some third term that was a unifying term. Maybe we need to create a little more ontology, a little more scaffolding to connect them. Or maybe they're just close matches with one another. Basically, every term in A, you go through and you see how it fits into B. And once you've gone through all of the things in A, then you're done. Then you have stitched the ontology. When I say you map them in, and I looked at each of those numbers, what are you going to map them in with? What is our stitching file going to look like? Well, it's going to use this vocab. Owl sameAs, when there are two individuals that refer to the same concept. Equivalent class, when you have two classes that refer to the same concept. And an equivalent property when there are two properties that refer to the same concept. These are the easy ones. These are like great. You sort of bolt in. We've matched something exactly one-to-one. But then we have subclass relationships and subproperty relationships. And then as it gets a little bit squishier, we can use the SKOS vocabulary. So SKOS has like near match, exact match, close match, broad match, narrow match, cards on the table. I don't love the SKOS matching vocabulary. It feels a little difficult for me to understand sometimes, and I'd rather just be leveraging the sameAs or equivalent class, equivalent property bits. And if I can't do that, I'm more often creating new terms that I can use subclass of or subproperty of to nestle these things under a common umbrella term. But the SKOS vocabulary does give you a lot to work with. So if you find you like that, go for it. And then we can also use for SKOS, there's narrower or broader if we have individuals that we refer to as categories that are related in a quasi-subclass, superclass relationship with one another. And then the last type of vocabulary you can use is make up your own. So if you have a relationship between a term and these two ontologies, and you don't yet have vocabulary to express what that relationship is, make up your own. You get to create all the colors you want to paint with when you're doing LRDF work. The other thing that's going on here that might be tricky are dealing with homonyms and synonyms. So suppose we had an ontology that was British English chips, and then we had an ontology that was US English chips. those two terms are different from one another. And so you might want to say that these are different from, or we might want to identify that two things are same as each other. And here I did crisps and chips being same as each other. It might be equivalent class if I have them represented as classes, right? So just a heads up on terminology there. Now, in this case, these things aren't exactly homonyms, probably. Notice they have different prefixes, but their short names of chips and chips are the same. And so they have like homonymous short names. And this is actually a pretty big issue because we want our ontologies to be both machine and human readable. And in cases like this, you have a couple of different choices. Same thing for when we deal with synonyms, different terms, right? Like crisps and chips that refer to the same concept. One thing that we can do is just say they're the same as each other, and we're going to prefer one of them or the other. So we're going to have like a deprecated term. So whenever we represent things in our ontologies or in our data set, let's use the US English version because this is a US company or something like that. Alternatively, we could leave both of them and say use whichever one you like at any time that you like. Or we could create a new term that is a single term that is somehow like an umbrella that both of them map into, and that's our preferred term. All right, we've considered the easy and the medium option. Let's look at the hard option when we are stitching together files that are overlapping and in tension. What does it mean to say ontologies A and B are in tension? That could mean that they just have competing worldviews. They see the world in a different way. More strongly, it could mean that they are contradictory in some sense. One says P, the other one says that not P about something. Or they could just be fighting over terms, like we were just talking about homonyms and synonyms. Maybe one of them really wants to have one of those terms, and they're arguing over who's the one who gets to use it. Let's see how we're going to handle each of these things. How are we going to resolve tension when there's just merely tension? Well, first we just make sure that it's mere tension. Let's identify cases where there are merely verbal disputes. It looks like these two things are in conflict, but we can actually harmonize them and make it so that they both come out true. So an example of this is maybe one team is telling you that phase one takes a week, and the other team is telling you that phase one takes a month. And this looks wrong, right? Is it a week or a month? This is a serious problem. But what you'll find as an ontologist, if you go and you ask some questions, well, why do you think it takes a week? What is involved in phase one? Then you find out, oh, I can create some generalization that will clear up this merely verbal dispute. Because what's happening is that acquisition takes a week, and site prep takes a couple weeks, and groundbreaking takes another week. And that whole process is 4 weeks. But one team was just thinking that phase one was acquisition, and that was what took a week. And the other one was thinking it's the collection of these 3 operations, and they take a month. So in some sense, you're both right. The issue here is just what do we want to use as the label for these phases? And let's call them now acquisition, site prep, and groundbreaking. And then we can clearly delineate what's going on. Nobody has to be too sad about this. And this might feel to you like a little bit of a Pollyanna-ish approach that like, oh, when things are in tension, just talk to everybody and then resolve the tension. But it's a little more plausible than you might think. I've got a picture of Leibniz up on this slide, and he was famous for thinking that, famous for many things, including delicious cookies named after him. But one of the things that Leibniz thought is that most of our disputes are because we're not clear enough in the language that we use. And there's really something to be said for that. He was very idealistic about what would happen. He said, if we make the perfect language, then there will just be no more philosophical disputes or arguments because we will all just see clearly what the truth of things are. I don't think that fixing things up in an ontology is going to be that clean, but it does resolve a lot more often than you think. But let's say that the views are not just in tension, they are really contradictory worldviews. How do we go about resolving them? And before I even get to the text on this slide, I got a picture of the globe up there because this is the whole reason why I think about our ontologies being a model of the world. And I believe that there are no true contradictions in the world. And because there are no contradictions, if our ontology just says true things about the world, then we won't end up with any contradictions in our ontology, and this makes me pretty optimistic about our ability to build ontologies that are contradiction-free. That's not easy because when we have interpretations of the world, those interpretations can get into conflict. And the first thing I want to encourage you to do is throw out false stuff. So much of the time, people get caught up in, I'm trying to harmonize these ontologies. How can I make them both true? But if one of the ontologies is just saying false stuff, it's like, get rid of that stuff, right? First and foremost, we should take contradictions to be an indicator of something false going on, clean those false things away, and then maybe the contradiction is now gone because we've just deleted the false thing. Let's say you can't do that. Then isolate what those contradictions are. It's not that the whole ontology A is contradictory with the whole ontology B. It's probably some subset of the claims, right? There are two claims such that one is P and the other one is not P. That's where our contradiction is. Once we've isolated that contradiction, we can figure out what we want to do with it. And this is going to be a hard choice because it's not clear which one's false, right? Because we've already thrown out the false ones. The first thing we could do is just leave out those two claims. If we can't choose over two claims that are contradictory with one another, maybe that should tell us we're not confident enough in either of those claims to put them in the ontology. So let's leave them out. Now we have more harmonized ontologies. Maybe we go do some more research and figure it out eventually which of those claims were true, but let's not put either of them in to start with. Alternatively, we could put both of the contradictions in, but put them in separate named graphs. So there we have one named graph that contains P, the other named graph contains not P, so there's no single graph that contains the contradiction in it, but we could find either of those claims in separate places, kind of, separating the fighting siblings into their bedrooms. Another thing we could do is just add a layer of abstraction. And this is dangerous, but it's a strategy worth knowing about. So let's suppose that I have medical records, and one of those medical records says I have hypertension, and another medical record says that I don't have hypertension. Now here's a contradiction. Casey has hypertension. Casey does not have hypertension. Those two things can't both be true. But I could say there's one medical record that says I have hypertension. There's another medical record that says I don't have hypertension. Those are both true and not contradictory. And then the last thing that we could do is just get over it. So maybe this is because you don't think it's that important, like we can have contradictions out there. Maybe it's because you disagree with my core claim that there are no contradictions in the real world. Maybe you think, look, the world just has contradictions in it. And if that's true, then why not have contradictions in my ontology? Because I want to say as many true things as I can. That's absolutely an angle you can take. Of course, there will be downsides to this one because OWL is designed thinking about like traditional classical logics. We do not want to have contradictions in those logics. Bad things will happen to reasoners, stuff like that. But strictly speaking, you can have contradictions in your turtle files. You just have to be careful about what other software and reasoners you put on top of that will be very unhappy when they find those contradictions. And then the last thing that I wanted to consider for ontologies that are in tension is when people are fighting over a term. So let's suppose something like client is going on. I'm hired by some organization. They want me to build a knowledge layer across all of their different teams. And the finance team has clients where they are paying customers. And the engineering team is talking about clients as in the things that are hitting their API and causing them problems. And they both want to use the term client, but it refers to different concepts. What do we do in this case? Well, we've already talked a little bit about strategies for unifying these things, where we can create some parent term or we can create some new terms to use instead of clients. And that's not too hard to solve in like a implementation architectural way. Just create a new IRI, put those things in. Or they could both have the same short name of client and they'd just be in different namespaces and therefore have different IRIs. That's fine. Again, you run into homonymy and synonymy issues when you do something like that. But the other point here is that a lot of being a good ontologist and stitching ontologies together is the political aspect of it. And I've talked a little bit recently on this channel about what it is like to work as an ontologist, how do you get a job, those sorts of things. And this is an important role for you as an ontologist. You play a little bit of therapist with the different teams. You're like a data therapist. You're like, okay, so you're using the term client. Why do you want to use that term client? Why is it important to you? right? And you're going to have to learn, what are the political dynamics at my organization? Is one of these teams more important than the other one? Do they have more data? Will there be more of a cost to us in having to restructure things? When you understand the full landscape, maybe you can make the right pitch here for who should get the doll, right? Who gets the term client? It just depends on what you can get your organization to buy into. But the important underlying piece here is, if we have things in tension as part of our language vocabulary model graph, we want people to be able to make use of that language. And the only way you're going to do that is to talk to them, get buy-in, figure out how they're going to use it and understand it. Don't just think, well, I'll fix this by just changing the term. If you change the term and nobody understands there was a term change or accepts it, then the people aren't going to use your ontology, and then you wasted your time building it. So think about how you're going to navigate the political situation here, because that can often be just as, or maybe even more important than handling the technical component of building the ontology. Semantics is all about connecting data, and this means we'll want to connect distinct ontologies, 2 or more of them. We can do that by stitching or grafting or welding or aligning them, and that involves identifying how they're related, whether it's overlapping or not, conflicting or not, and then making a beautiful quilt or Frankenstein, whatever you like. Oh, this was a fun video to make. I hope you enjoyed watching it. I hope you learned stuff. If you run into issues as you're trying to stitch together ontologies yourself, or you've run into issues in the past, have things that really work well for you, drop it below. The comments help the algorithm. Like and subscribe. Request future videos. I'm having a blast. Let's keep it going. I'll see you guys in the next video.